Hello, I'm MC Toon. Now, recently, Austin Witsit, or Witsit Gets It, had a debate on Agree to Disagree against Ranty, formerly Ranty Flat Earth, now just Ranty, who is not a flat earther anymore. Now, Austin is one of the globe busters, and I've debated him several times, and I'll link the debates in the description. In this particular debate, Austin had agreed to specifically address some aspects of the photograph that that convinced Ranty that the Earth is not flat. So here is the introduction to that. I'd pay close attention to Austin's response to Ranty's very specific question.
Yeah, I was hoping Witsit could explain to us, the three criteria we went through: the trigonometry, the visual effects of the mountain, and the pixel count. Why you can't use them to determine what's going on here and how that conforms to this being a flat Earth image.
All right. So, how does trigonometry not work as the way you're applying it? Well, you're taking certain angles and then you're not accounting for refraction at all. In addition to this, as to the question that he just now said this is all about, does this work on a flat Earth or a globe Earth? Well, if you're going to take the angular change over distance into account, then you're going to have to apply that to your Earth curve calculator. But none of the Earth curve calculators account for angular size change with distance. So we actually can't compare the geometric nature of your trigonometry, not accounting for refraction, with the Earth curve calculator because it doesn't account for angular size change with distance. So we would expect to see this on a flat Earth, just like the time-lapse show. There's a constant fluctuation of the mountains because it's just an apparent location. The globe Earth claims that what we see is obstructed physically. A physical Earth curvature is called geometric horizon, so it should be consistently physically obstructed based on the radius value relative to your observer's height in feet, but we don't see that. We see a constant fluctuation. In addition to that, of course, you can see the tower, and it appears to be taller because it's significantly closer, so it's actually had less change over distance. It's just angular size change with distance. In addition to that, the beginning or the front of the mountains is the lowest part of the mountains. The highest altitude of the mountains are actually further back away from the observer, so we would expect to see greater change of angular size in the highest part of the mountain, which is what we see. In addition to that, to claim that there is physical obstruction of Earth curvature, you'd actually have to see the bottom of the mountain. It's clearly obstructed by the land in between us and the mountain and everything on that landscape. So, of course, we don't see the bottom of the mountain. So to say, basically, implicit in your claim is that this is impossible on a flat Earth. But no, it literally isn't. That's why you had to chop out the left side of the image that shows the horizon significantly further away.
And that is the essence of Austin's response. He didn't actually do any analysis of the photograph. None. He essentially claimed that Ranty didn't do the geometry calculations right. He's wrong about that. I'll get to that in a second. And that since Ranty didn't take into account refraction, that none of it even needs to be considered. Now, did Austin, instead of, just denying it, did Austin do the analysis with refraction? No. Did he do the analysis that he thought was the right way with perspective and angular resolution and angular size? No, he didn't do anything. All he did was identify things that he thought must be done and then refuse to address them. So there's a bigger problem, though. Austin gave away the whole thing here, and he doesn't even realize it. He said something that's totally backwards, but in it is an admission that he's lost.
To claim that there is physical obstruction of Earth curvature, you'd actually have to see the bottom of the mountain.
Did you catch that? Austin said that in order to prove the curve, you'd have to see the mountain behind the curve, but you can't see the mountain. Therefore, see, the problem is he admitted that you can't see the bottom of the mountain, but for some reason he thinks that on a curved surface you should. Well, of course, he's wrong. On a curved surface, you should not see the bottom of the mountain. And he just admitted that you don't see the bottom of the mountain. So he defeated himself very thoroughly right there. Now, he spent the rest of the debate trying to not talk about the height of the tower in relation to the height of the mountain. Instead, he focused and diverted and deflected everything to this, what he thinks would be the horizon, which, of course, in this picture, there is actually no good horizon where the sky and the surface of the water or something meet. It's not even in this picture, but he spends the rest of the debate trying to talk about that and somehow talk about how it's necessary. So here's the critical part. Just listen to this.
You're saying this isn't possible on a flat Earth. It doesn't in any way show the obstruction needed for a globe Earth. It's only possible on a flat Earth because it debunks the radius value also. I'm just saying it isn't where the geometric horizon would have to be. The geometric horizon is certainly not present where it needs to be.
So there is Austin's claim that the horizon isn't where it should be for the globe. Did he include any analysis for this? He did not. But it's a very specific claim that Austin made. Now, Ranty does a great job and asks Austin to back up his claim.
You made a claim that the horizon is further than where it should be. You've made a claim that the horizon is further than it should be. Now, you made the claim that you could see further, and I'm asking, where are you seeing further in this image?
Yeah, so Ranty is being very, doing a very good job here, because Austin has said that the horizon isn't where it must be. And Ranty says, well, show me the analysis that says that this isn't the case. But here's the great thing. This is Austin's answer when Ranty is saying, provide evidence for your claim.
You actually are effectively committing a reversing the burden of proof fallacy, because you're acting like I need to prove something here, when the truth is you're invoking this saying it's impossible on a flat Earth because the Earth's a ball. Well, we were told a specific size that the Earth, that being a ball, is. It's a radius of 3959. So I'm asking you, are you saying that this is the geometric horizon that we're seeing to the left? It doesn't in any way show the obstruction needed for a globe Earth. It isn't where the geometric horizon would have to be.
Yeah, that's the standard procedure for Austin. First, he makes claims that he doesn't make any claims. Then he makes a bunch of claims. Then when you ask him to back up his claims, he reminds you that he already said that he doesn't make any claims, and then says that it's a reversal of burden of proof fallacy, because he obviously doesn't make any claims, because he says he doesn't make any claims. But it's actually just a double reversal of proof fallacy, because he did make claims that the horizon isn't where it needs to be. Now, I got to remind you, you don't actually really see the horizon in this picture anyway. It's not even set up to see that, because there's water and ground and mountains behind it. You never really see that. So it doesn't matter. But now you may be wondering, why does Austin talk about the geometric horizon so much? Well, he is in love with the words geometric horizon.
Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. Geometric horizon. The geometric horizon. 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 Geometric horizon.
Yeah, the sad thing is that's not all the times that he said geometric horizon. So, yeah, Austin can't stop focusing on the geometric horizon, which we really don't see in this photo. Ranty appeases him for a little while, but the agreement was that Austin was going to come on and talk about the specific thing, the height of the tower, the height of the mountains in the background, and address that particular thing, to do some analysis on it and show how it doesn't match a globe and how maybe it would match a flat Earth. So here is a good section of Ranty asking to get right back to the specific topic that was agreed upon by Austin, and, well, see what Austin does.
We're sticking to this particular part of the observation. So the first point was, could you use trigonometry? I showed that trigonometry matches the globe. When you actually put the drop values in and you actually, use it properly using the trigonometry, you can actually determine that it matches up perfectly to a globe. So the next question is going to be, how in the pixel count did you disprove Ruhif's points?
Wait, no, why didn't you actually respond to my rebuttal to the trigonometry? Do you account for refraction in your trigonometry when you apply it to the presupposed fairy tale globe model?
I didn't use that, no.
So you didn't account for refraction at all, and you basically assumed that there was literally no refraction in this image?
Well, in what refraction would you be trying to claim is happening here in this image?
Wait, I just wanted yes or no. Are you saying that there is no refraction?
I didn't say that. I said I didn't calculate for it.
So then you don't have an accurate calculation if you didn't account for all the variables, then, do you?
Well, it wouldn't be accurate because the refraction you'd be trying to impose on me would be 7/6R, which would be essentially seeing more. But what you would have to invoke here is a reverse, a sinking calculation. So whatever calculation I was to put in with refraction wouldn't match anyway, because you would have to try and claim some kind of sinking going on here.
No, you're having to claim that this is a physical obstruction of a geometric horizon, and then you're using trigonometry, applying it to the globe Earth, the presupposed maths, and you're not accounting for refraction. And then you're not accounting for angular size change over distance on the flat Earth, then accounting for refraction and how it's going to obviously change more the further away you get from the observer, which is exactly what we see. The mountains are way further than the tower, bro. That's why they're way smaller whenever it comes to the actual amount of change that it's experienced, because it's further away. I'm asking you, did you account for refraction, or have you just thrown out a very important variable and then claimed that your calculations are accurate simultaneously? Because that's not working out, bro. That doesn't make sense.
So Austin is demanding that Ranty include refraction. Now, Ranty warned him a little bit here, because including refraction in something like this is not a large effect, but the effect does the opposite of helping flat Earth, because refraction causes distant objects to appear slightly higher. And the distant objects are already too low. So including refraction would make the mountains lower, right? And they're already too low. So it doesn't help you, Austin, but he still insists on demanding that it be applied. I think completely oblivious to the fact that it would not help him. It will hurt him. Well, so Ranty does exactly what Austin asks.
It seems to me that you're just a little bit upset because I didn't include any kind of refraction in my calculations. Nothing to do with Ruhifs, nothing to do with conspiracy cats either, but just particularly mine, right? So you're focusing on that, and you think somehow that if I then include refraction, it's going to make it better for you. Is that right?
Well, if you can't adequately account for refraction, you can't make a claim about the apparent location. Now, can you, Ranty?
Okay, so let's pop this in. Let me share my screen again.
Are you going to account for refraction now, Ranty?
Yes, I've just put the calculation up there. So here I am accounting for refraction just so that Witsit is happy. And instead of the geometric hidden, where are we? Geometric hidden, where is it? Geometric hidden, 375 meters hidden. It's not changed that much, has it, Sunshine?
Okay, so you think that this is the accurate quantification of refraction. So you do see that this invokes the radius value, correct?
You wanted me to include refraction. I've included refraction for you.
Well, you're including your version of a presupposed refraction based on a presupposed dimension that's literally in contention, right? So when we say the Earth's not a ball, it's because we went and measured the Earth, bro, and it doesn't have the convexity rate of terra firma consistently obstructing our view physically that it would literally have to based on a geometric necessity.
So there it is. Ranty did include the calculations for refraction, and Austin's answer to that is a big nuh-uh. He says that somehow you can't explore and test whether or not the Earth is a sphere by using refraction and the other things about Earth being a sphere. Somehow he can't use that. And then he claims, this is great, he claims that it's not obstructed enough. But he already said this.
And we can't see the bottom of the mountain.
Yeah, that's right. Austin gave it away here. He said that you need to have stuff obstructed, and then says that there is stuff obstructed for the globe. So he's kind of shooting himself in the foot again. So now Ranty, he goes right back to the topic, and Austin was demanding that when Ranty compares the viewing to a flat Earth, that he include refraction. Right. And how is Ranty supposed to include refraction for flat Earth? Don't know. He's asking now. He's going to ask Austin right now for that.
So my question is, if we're not using globe refraction, can you show me, like I'm showing you the calculation, can you show me your calculation then that's going to tell us how half of that mountain is hidden behind the tower, right, below eye line, on your flat plane? Can you please provide a citation or some kind of calculator that shows me where that is?
I would just like to remind the entire audience that just a few minutes ago, Ranty had these two pictures up, and one of them was globe Earth and one of them was flat Earth. He then went to proceed to beat up a straw man model that no real flat earther claims, because we can actually verify a model and their reification fallacies. He tried to beat up a straw man model of the flat Earth, right?
Yeah, so anytime Ranty tries to make a prediction for what you would see on flat Earth, Austin says that's a straw man, because he doesn't have a model. Of course, Austin does have a model. He says the Earth is flat. He said it many times. That's a model. He doesn't describe his model well. He tries to claim that he doesn't make claims, but he makes claims that the Earth is flat. So that's a model. So then it's this hypocrisy of you can't explore the flat Earth model, but oh wait, you need to explore the flat Earth model.
He has to account for angular size change with distance and for refraction, showing how it wouldn't work on a flat Earth. He's never done this.
Yeah, so Austin can't have it both ways. Either Ranty needs to test the flat Earth model or not test the flat Earth model. Maybe Austin, the point of it was for Austin to show how it did work on the flat Earth model, but he refuses to do that. Ranty is very patient and asking, could you provide the details for how refraction should work on a flat Earth, since Austin is very resistant to allowing Ranty to do something like that. He goes round and round several times, refusing to address that very specific thing that was the agreement of this debate. And now Crafty Keela, the moderator, she does a fantastic job. She's holding the interlocutor's topic to the topic. Austin had agreed to talk about this, and she's saying, let's address this very specific thing. And his spiral goes a little crazy here. Have a look.
So, sorry, Witsit, can you actually answer the question that he asked you to answer instead of trying to appeal to the audience for what you think has happened here? Can you actually answer what he's asking you?
I did just answer what he's asking me. He's asking me to give my calculations, but his entire premise is that he's shown that this doesn't work on a flat Earth, but he didn't even account for refraction over a flat Earth and work that into his calculations to sufficiently propose that it wouldn't work on a flat Earth. He then went over and stumbled. No, that's his job, because he says that this doesn't work on a flat Earth. He's making that claim. He said that he mapped it out using trig and everything to show how it's impossible on a flat Earth, yet he didn't even account for refraction. When asked for refraction, he went back to the globe Earth and used 7/6R, which assumes the radius value, and it doesn't even have anything to do with the atmospheric conditions. So he can't explain how it couldn't work on a flat Earth. We know it can work on a flat Earth.
That's what I'm getting from you. I don't mean to be disrespectful, and I don't like interrupting, but you came into this debate. You don't have, because I don't have your figures. You were supposed to bring your figures to show how Ranty's figures are ridiculous. You didn't bring any of that. So
I just showed why his figures were ridiculous. Are you moderating or debating? Am I missing something here? Because both of you are trying to help Ranty out because he's getting decimated, but I'll just leave.
Answer the question. And you
I just did.
Answered the question.
I won't subject you to the other dozens of times that Austin was asked to provide the analysis that he did somehow to show that it wouldn't work or that it would work for flat Earth. He never does it. All he does is say the refraction and angular size must be accounted for, and then he doesn't do any analysis of it. When Ranty does analysis of it, he calls it a straw man. So you can't have it both ways, Austin. Show how it works or just, wave that white flag, I guess. Now, and he's pretty upset. He's pretty worked up because he thinks he's answered the question, but he hasn't. He has completely deflected every time he can away from answering the specific question of show me the analysis that needs to be done. So anyway, he goes in his final comment after talking about refraction, literally talking about refraction over and over and over for an hour. He says this.
If you want to prove the Earth's a ball, you need to go prove a consistent geometric horizon that's physically obstructing your view consistent with the radius value of 3959. That's 1.225 times the square root of the observer's height in feet. It always has to be there. It's never there.
Now, other than the obvious thing that there are many ways that you could establish that the Earth is a globe, like maybe a photograph from it from a long ways away, or measuring it using surveying methods. Any number of ways that you could do it. He ignores that and says the only way that he will accept is establishing the geometric horizon. Now, he does that because it's his script. He only has one thing that he can do. He only has one script. He can't analyze other things because it's not in his script. Now, where did he get this script? He got the script from Quantum Eraser, or QE. And QE, he doesn't know enough about how to do this. He got the information from Andrew Young's website. Now, Andrew Young is a professor at San Diego State University. Very smart guy. One of the best experts in the world on the effects of refraction, on how light passes through the atmosphere. And right here on his website, you can see he does an analysis of how far the horizon would be away from the observer's height. But if you look at the top there, it says no refraction. Now, what does Austin say about not taking refraction into account?
I'm claiming that you haven't even actually accounted for all the variables, and you're touting your trigonometry that literally hand waves dismiss one of the most important variables when it comes to perception, which is refraction. Refraction always happens. That's why it's important. Refraction, which we immediately and adamantly claim is always present, because there's temperature fluctuation and atmospheric conditions that are consistently affecting what you perceive. Well, if you can't adequately account for refraction, you can't make a claim about the apparent location, now can you, Ranty? Refraction increases proportionate to the distance, and never in your dissecting of the observations do you even account for refraction that we know for a fact to be present, and refraction, because you're increasing refractive effect proportionate to distance. So the more atmosphere you have in between you, the more refraction you have, because the more atmosphere that's there. When you just throw refraction out entirely, invoking the furthest point away in the image and saying that you don't have to account for refraction, and making the baseless assertion it doesn't move it, because you showed us some really not very great images where they look to be generally the same, is laughable, bro.
So thank you very much, Austin. That's 8 different times, and there's a few more in here, where he said you've got to take refraction into account. So I completely agree, Austin, and I look forward to you calling out everybody in the flat earth side that ignores refraction when talking about your supposed Black Swan photo. Yeah, gotcha. What do you think about that, bro?
Sounds good, bro.
Bro?
Bro.
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 Can you believe people let me come stay at their house?
Nathan, this video isn't about you, bro.
Cool story, bro.
So as you saw, this debate was very much about Austin not doing what he had agreed to do, provide some analysis of the particular photo. And instead it was both Ranty and the moderators prompting him to provide the analysis that he refused to do. But we did get one very good thing out of it. Austin is adamant that you can't do any analysis without including refraction. So thanks a lot for that. Well, thanks for watching. I do debates against flat earthers like Austin myself every week, usually on Tuesday nights. So be sure to subscribe and click the bell notification so you know when that happens next. And thanks a lot to my members and patrons. We'll see y'all next time. Bro.